Okay, so let's get into it. If you're managing any kind of modern server environment, one of the NTI systems like the E2D or E16D, you always hit a limit.
You do. It's that physical I/O wall. You just run out of ports for sensors, for controls, and you really don't want to start pulling new cable everywhere.
Exactly. And that's where this device comes in. We are doing a deep dive on the NTI E-DI16DO16 digital input-output expander.
Right. And you should think of this as a force multiplier. It's a small box that takes one single RJ45 sensor port on your main unit.
Just one.
Just one. And it turns it into 32 separate points of contact. 16 in, 16 out.
32. So, that's the definition of efficiency. So our mission today is to break down how that actually works and, maybe more importantly, what it lets you do.
Let's start with the inputs, the monitoring side. You get 16 digital inputs, which is your foundation for just seeing what's going on.
And these connect using screw terminals for dry contact devices. That sounds a little jargony. What does that mean in the real world?
Yeah, it's a simple concept, but it's really crucial. A dry contact is basically just a switch. It doesn't have its own power. So think a door sensor or a simple float switch in a tank.
Okay, got it.
And the inputs are potential free, so they don't carry their own voltage. This makes wiring a lot simpler, a lot safer. They're also pretty tough. They can handle up to plus 36 VDC, and they have surge protection built in.
That robustness is key. But I saw something else in the spec, something a bit unique. There's a dedicated terminal just for a tachometer. Why give that its own special input?
Ah, that's a strategic little bonus.
Mm-hmm.
Because if you're monitoring, say, a generator or a big cooling fan, you don't just want to know if it's on or off.
You need to know how fast it's running.
Exactly. You need the RPMs.
Yeah.
This input handles 0 to 255 hertz, giving you that vital data without you having to burn one of your general purpose inputs on it.
Okay, so that covers the seeing part. What about the doing? How do we use this thing to actually control something remotely?
That's the other half of the equation. The 16 digital open collector outputs. These are your actuators. They're what let you flip a switch from miles away.
So we're talking about controlling things like relays or maybe some indicator lights.
Relays, solenoids, LEDs, you name it. They're designed for exactly that.
Now I hear open collector, and my mind immediately goes to low-power signaling. Does this box actually have enough juice to trigger something substantial?
It absolutely does. They operate from 0 to 24 VDC. The key number here is the sync current. It's rated at 500 milliamps per output.
Oh, 500 milliamp. Okay, that's not trivial.
No, it's serious capacity. You're not just lighting up a tiny LED.
Yeah.
You have enough power to engage a heavy-duty relay that could, reboot a stuck piece of equipment or shut down a pump.
This is where it gets really strategic for me, the scale. With standard CT5 cable, you can go about 500 feet, which is, 150 meters? That's good, but maybe not enough for a big campus.
That's just the baseline. This is the real aha moment. The expander is compatible with the EFSC fiber converter.
Oh,
Once you bring fiber into the mix, you can extend that connection up to 1.2 miles. That's 2 kilometers away from the main unit.
Hold on, 1.2 miles of remote I/O from a single port. That completely changes the game. That changes the whole financial picture for a distributed setup.
It does.
So how are you managing all this? How do you actually control it from the IT side?
It's all managed via SNMP, Simple Network Management Protocol, so it plugs right into the monitoring tools you're probably already using.
And there's a key difference between the inputs and outputs, right?
The digital inputs are read-only. They're fixed values telling you if a switch is open or closed. But those 16 open collector outputs, they are fully writable.
Meaning you can send a command.
You can remotely send an SNMP command to toggle them. Turn a relay on, turn a solenoid off. All it takes is the right community string settings. It turns this little box into a fully two-way remote control hub.
That is just immense functional density. A little powered by the system unit that's not even 7 inches long. And for anyone who deals with procurement, it's TAA compliant and RoHS approved, which is always a plus.
So here's the final thought for you. Since this one little expander gives you both monitoring and control over distances of more than a mile, think about what that means for integrating your most dispersed physical assets.
Things like remote utility cabinets or security gates on the far side of a campus.
Exactly. Think about the strategic advantage of pulling all those distant isolated points into a single central monitoring dashboard without having to pay for a dedicated network drop at every single one of those sites. What could you control if distance was suddenly no longer a barrier?